All right, we are continuing our study of functions in 4.4. The start thinking part here says that you have the table to the right, and it says analyze the following and try to determine the unknown value. So I already had 1 and 8, 1.5 and 7, 5 and 0, and -2, and then it was a question mark. The students were supposed to try to figure out how the people came up with 8, 7, 0, and then use that same method to come up with that last number. It took a little while, but the students finally figured out that since there is an x inside of the function and then the x changes to a number, they must just be changing the x to be that number. So the way that they got the 8 when you have x equaling 1 is you just substituted in a 1 for x. Then you substituted in a 1.5 for x. Then you substituted in a 5 for x. And then you would substitute in a -2 for x. So when you substitute in a -2 for x, you can see this. Instead of saying f of x, you could say that is f of -2, meaning that you have a input of -2. When you put in a -2, you are going to spit out a 14 as your output. The main purpose of this lesson was to make sure that students could write a function in many different ways. Number one, they could write a function as an equation in function notation. Number two, they could understand that a function can be described in words. Number three, a function could be written in a table. And number four, a function can be drawn as a graph. That's what we were looking at. So when the students went to this next part that said functions in words, it was basically just trying to figure out which one of these functions, f of x, g of x, h of x, and k of x, which ones matched up with each one of these words. The first one says to get the output, subtract 7 from the input and then divide the result by 3. Now, when you look at all these ones, they all have 3s and 7s in it, but the one that made sense, because an output is your f of x or your g of x or your k of x or whatever it is, and your input is going to be that x, it says subtract 7 from your input, so subtract 7 from x, and then divide by 3. That was true for the bottom function. So when we went through all these, the students were able to find that the top one matched up with C, the second one with B, the third one with D, and the last one with A. So those were the words that matched up with each one of these functions. The next one, number 2, says for one of the functions, the input of 6 is going to have an output of -3. So that is basically saying, does f of 6, g of 6, h of 6, or does k of 6 equal -3? And we found out that it is for g. So g of 6 actually equals -3, because when you substitute in a 6 for x, it will spit out a -3 for g of x, also known as y. The next ones where you were supposed to be trying to figure out which one of them is going to be greatest for 0, meaning is f of 0, g of 0, h of 0, or k of 0, which one is going to give you your biggest output. So what you can do is you can substitute 0 in for each one of your x's in here, and then after that, you would see which value is going to be coming out as your output. It turns out the last one, k of x, when you substitute in 0, so k of 0 is going to give you your biggest value, which is -7/3. They then want you to do the same exact thing for an input of 10. So basically you were trying to figure out what is f of 10, g of 10, h of 10, and k of 10. What are those all going to be and which one is going to be the biggest? And when you substitute in 10, you find out that f of x, whatever you have for that function, is actually going to give you your biggest number, which is 23. So f of 10 is going to be 23, which is your largest output. So at this point, we have studied functions. After we've studied functions, we've looked at functions and connecting them to words and function notation. Now what we need to do is students need to be able to describe and show functions as tables and graphs. So in this one right here, they're talking about a square, and they say if a square has a side length of 9, its area is going to be 81. So students need to know that squares are going to be four-sided figures with all sides being congruent and all right angles. So we know that for rectangles and squares, to find out what the area, it's just base times height. So that makes sense that if it is 9 centimeters, then the other side's going to be 9 centimeters, and you're going to get an area of 81 centimeters squared. So on here, what we're going to do is first complete the table. So if it had a side length of 1 centimeter, then it's 1 times 1, which is 1. Then if it had a side length of 2 centimeters, it'd be 2 times 2 is 4. We fill out this whole entire table, and then when we get to the end, what's nice is we've already seen what we did with things that we're comfortable with, which are just numbers, and we did the same thing when your input is no longer a number, it's a variable. So when it was s, we knew that we just took the numbers before and squared them, so when it's an s, we just square that. So you have s squared is what the area is. And when you want to write it as, for part A, when it says write it as a function, we're talking about the area with an input for side. So that would be A of S. You can see it right there, equals S squared. So when you input whatever a number is for S, it will spit out your area, which is A of S. The next says, what does A of 2 represent in this situation? It just means the area when the side length is 2. It does not just mean the area. It does not just mean when the side length is 2. It means the area when the side length of 2 is 2. And then it asks, what is that value? And it is 4. Now we did the same thing on this one right here. This is saying you have a giant roll of paper. It is 3 feet wide, and you can pull out as much as you want. You can pull out an inch, a foot, 2 feet, 3 feet, 10 feet. You can do whatever. And when you cut it off, you are going to have a new figure. That figure will have both an area and a perimeter. But this question is asking about the perimeter. So when you pull that off, the first part says, what about if you pulled out 2.5 feet? What would the perimeter be? It's always good to make sense of a problem by drawing the picture. When I cut that piece of paper off, it's going to be a rectangle. It's going to be 3 feet on one side and 3 feet on the other side because I can't really change that aspect. I can change how much I pulled out. I pull out 2.5 feet. Since we're talking about perimeter, let's just add all those up. And when you add them all up, you get 11 feet. Okay, it's not feet squared because it's not area, it's just 11 feet. The next part says, I want you to do the same thing, but we are going to be changing the values of the side length. Figure out what the perimeter would be. Now, I kind of like when I'm getting used to writing these function rules, it's really nice to be able to see my work with numbers, and then that way when I go to a variable, I already know what needs to change and what doesn't. So when you have a rectangle, and you have pulled out 1 foot of this, you know you're going to have 2 sides that are going to be 1 foot and 1 foot, and 2 sides that are 3 and 3, because the 3 part is just set. So it's 2 times 1 plus 3 times 2. And then when you have a side length of 2, that's going to be 2 sides that are both 2 each, and then 2 sides that are 3 each. The next one will be 2 sides that are 6.3, and 2 sides that are 3 again. Then 2 sides that are 11, and 2 sides that are 3. You can imagine pulling out this piece of paper. 2 of the sides are always going to stay at 3 because you're pulling it off the roll that is only 3 high. So once you get that, what's nice is we were able to find all the perimeters, but not only that, you can see the things that are changing and the things that are not. That first 2 does not change ever, so it stays as 2. The other one kept changing based off of how much length came out. It became 1, 2, 6.3, 11, and then when it's L, we just put it in an L. The plus stayed as plus, we keep it as plus, the 3 stays as 3, and the 2 stays as 2. So we find out that the equation is going to be 2 times the length plus 3 times 2, which I just made into 6. You can see my function notation, which is just P of L equals 2L plus 6. Input of L, and then the perimeter would be P of L. Just function notation, getting used to it. What they did then is they say, what does P of 11? What does that actually mean? Most kids know that that means a side length of 11, but they don't realize there's 2 pieces of information. This is the perimeter with a side length of 11, and that value, as we already calculated, was 28 feet. Next, they wanted us to represent this function not only in words, not only in function notation or as a table, but also as a graph. So I plotted the points that fit nicely on my graph. And then I tried to ask myself, should I connect my points? And I knew that I could have a side length of like 1.23578 feet. So I knew that I want to account for all of the numbers between these points. The only one that kind of didn't really make sense was a side length of 0. If you don't cut anything off, it's not really going to there's no object to find the perimeter of. So I just said that value does not make any sense. All right. So once again, functions. We talked about functions as words and function notation as tables and as graphs. Now let's go ahead and go over the homework. So on this one right here, this is seeing if you could look at these ones that are in function notation and figure out the words that go along with it. You can see which ones match up with which ones. Let's make sure all this is correct because I'm the king of messing things up. Let's see, to get the output, multiply the input by 2 and then add 4. I agree with my answer for A. The next one says, get the output, add 4 to the input, and then multiply by 2. That is correct. The next one is going to be to get the output, multiply the input by 2, then add 4. That one would be correct as A, so I got them all correct. On the next one, it is talking about a square, and you're talking about perimeter. You need to know that all sides of a square are going to be the same. So if you wanted to find out the perimeter, if you had a side length of 0, it would be a perimeter of 0. Then when we go over and we have when we have 1, it's 1, 1, 1. That is 4. Then 2, 2, 2, 2. I think I accidentally only said 3 ones, but it was 4 ones, which gets you 4, and then 4 2s, which gets you 8, and 4 3s, which gets you 12, and so on. So we're able to generate this thing by substituting in our numbers. Then you need to come up with a generic function notation. This is the rule. And what we found was just whatever the side is, which we are calling x, you are going to multiply by 4. So p of x, the perimeter when the side length is x, is going to be 4x. Then it says sketch this out. I went over and plotted my points. Since you can have a side length of like 2.1357 inches, then I connected my points because it is continuous. The next problem here says you have two different functions, f of x and g of x. G of x is a little bit more complex, and it wants to know what is f of 4. And then in your copy, it says write it as a point. So f of 4 just means substitute 4 in because 4 is your input. When I put 4 in, you end up getting 8 plus 3, which is 11. And that can be written as a point 4, 11. The next one, when I substitute 3 in, you get 3 squared, which is 9, plus 6 plus 1. And that is going to give you 16. That's the point 3, 16. The next one says, if f of x equals 11, what would the x be? So what I did was I put an output in f of x as 11. So f of x was 11, and I was trying to find out what my x was. I just solved, and I found out that that was an x value, an input of 4. So it was 4, 11. The next one says an equilateral triangle has 3 sides of equal length. Function p gives the perimeter of the equilateral triangle with side length s. Remember that an equilateral triangle is going to have all the sides that are going to be the same length. So when they say p of 2, that is basically saying what is the perimeter when a side length is 2? So it's 2, 2, 2, which is 6. The next one says what is p of 10? What is the perimeter when the side length is 10? 10, 10, 10 is 30. And the last one is what is the perimeter when the side length is s? SSS is going to be 3s. So p of s equals 3s. The next one says the function c gives the cost in dollars of buying n apples, and it wants to know what does c of 10 equals 9 mean? Is that the cost of buying 9 apples, or does it give more information than that? Or is that wrong completely? Is it the cost of 9 apples is 10? Well, we already know the input is 10, so it's talking about 10 apples. So it might be C or D. The reason it's not C is because C is not telling you all the information. That doesn't just say there's 10 apples. It also tells you what the output is, the cost, which is $9. So 10 apples equals $9. The last problem here was just review. It's covering, do you know how to graph lines? Do you know about slope? Can you graph using x and y intercepts? Dotted versus solid, and which way to shade? So on the first one, I chose to graph using x and y intercepts. I found out the y-intercept was -3 by putting in 0 for x. Found out the x-intercept was going to be 6. I knew that it was going to be a dotted line. And then I tested 0, 0, and since 0, 0 did work, 0 is less than 12, I shaded towards 0, 0. The next one I started at 6. I went down 2 over 1. It was a solid line. And when I tried 0, 0, 0 is less than 6. So that worked, so I shaded towards 0, 0. And then the last one, that is a vertical line at 1. I tried 0, 0. Is 0 greater than 1? It is not, so don't shade towards 0, shade in the opposite direction. And you can see the part that I shaded would be the solution to the system because it would be shaded by all of them. All right, hopefully this makes sense. Just the main things are, remember, a function is something where every input only has one output. You've got your function notation, which makes it very easy to talk about functions. Functions can be written in function notation as an equation, a table, a graph, or in words. Thanks for watching.